Don't start with the ratio test. You could try just comparing it to something, right? Either you show that it's smaller than something that converges or that's bigger than something that diverges. The challenge here is you have one target, this -1, right? So Solomon and I were looking at this earlier. You could write it as the sum 2n over 3 to the n. Like, it's actually the wrong direction there, right? It goes like this. No, it goes the other way, right? Like this. Sorry. It goes like that, right? We made it bigger. We made the denominator... we made the denominator bigger, so what happens to it? It's smaller. Like that. Everybody with me? So what does this equal? Well, that is the sum. I mean, this feels good, and you will do ones like this. That's the same as that, right? What type of series is that? It's an infinite geometric series. And what's the R value? It's less than 1, therefore it what? What does this do? Converges, right? So if this was what we wanted, well, it would be helpful if we hadn't figured out that it is less. What do we have now? This thing right here converges, right? What we want is greater than that. No, you made the denominator bigger. By getting rid of the -1, you made the denominator bigger, so therefore you made the fraction smaller. Bigger denominator, smaller fraction overall. Does this tell us anything? Greater than converge equals, you don't know. So you need another test. Anybody have a test that you want to run on this? What do you think? So comparison doesn't work. Let's do the limit comparison. So the limit comparison, you need something for it to go to war with. You need something that you can throw at that'll result in a tie. So what did we just figure out, though, that it's really similar to? It looks like it's similar to 2 to the n over 3 to the n, right? What do we know? We know that this converges, right? So we're going to call this one bn, and we're going to call this one what? It was called an, by the way the book does it. And what are we looking at? We're looking at the limit as what happens? The n goes to infinity of an over, and we want to see what happens. So in this case, what is that? That's the limit as n goes to infinity. And what's an? 2 to the n over 3 to the n minus 1. And I'm just going to multiply by the reciprocal. What's the reciprocal of the original? 3 to the n over... I'm just multiplying by the reciprocal instead of... I want to skip writing something out here. Does something cancel here? Goes like that, right? So now what do we have? We have the limit as n goes to infinity of 3 to the n over 3 to the n minus 1. What does that equal? That is 1. What does the limit comparison tell us? It says that if c is greater than 0, then an and bn must both converge or what? Both diverge. But what do we know bn does? We know that bn converges, right? In this case, bn converges, so therefore what must be 2? Therefore, an converges. About what? Looks like it's about 1 over n, right? And what does this do? Diverge. So our feeling is that this diverges, right? Is a feeling good enough? No. Don't vote that way. Don't do math that way. So, diverge. It diverges, but we need to prove it. Don't forget basic algebra. Can you break this apart into 2 fractions for me? 4 sine n over plus n over n squared. Can you break this into 2 sums? Yep. 4 sine n over n squared plus the sum of what? 1 over n. What does this do? That diverges. We know that for a fact because what is it? It's the harmonic. Yay, it is the harmonic. It definitely diverges. We're not done yet, though, because we need to really verify the other one doesn't somehow bring that divergence back to convergence. We know what this is, though. We can figure this out. What happens here? What does this go between? What's the biggest this is? 4. And the smallest is 4. It goes between -4 and 4. How big can this get? Infinity. It gets infinitely big. It goes infinitely big. So this is really just some constant-ish times what's going on with 1 over n squared, right? What does 1 over n squared do? What does 1 over n squared do? Because it's a p series, we know that this right here, the way we can say this is, technically speaking, the side note is, we know that this, 4 sine n over n squared is going to be less than what? The sum of what? Which sum? 1 over n squared, right, exactly. And what do we know 1 over n squared does? It converges because it's a p series. P is greater than 1. So if it's less than convergent, what does it mean about this? Okay, so now we have half of it, this part of it converges, but the other half diverges. So what does the sum do? It goes to what? It diverges.
Why? Is that just the thing?
If something is infinitely big and we add 5 to it, what does it stay? Correct. That's why.
That's just something to memorize. If you have a convergent plus a divergent, it's still divergent.
Correct. Finite can't do anything to infinite. Okay. It's really helpful too to realize that, because let's say you had a series that just went like totally crazy, right? But then it started doing something really nice. You can always cut this off if this is finite. If you take something finite away from something that's infinite, does that change the behavior of convergence or divergence for the infinite part? No. So if you show that this is convergent or divergent, the whole thing must be convergent or divergent. The thing you have to be careful of, though, is multiplication. Who wins in the epic battle between 0 and infinity when you multiply them?
0, 1.
Exactly. Neither one. You don't know. It depends. It depends on how fast something is going to 0 and how fast something is going to infinity. There are 3 possible answers. 0 wins, infinity wins, or it's a tie. It's a tie, and the answer is like 7, right? Like, for example, remember this? What was it? N sine 1 over n as n goes to infinity. This gets infinitely big, right? What does this do? Infinitely small, right? You remember what this limit is? Hey, it's a tie. I love those. Those are cool. You have something infinitely powerful against something else that's infinitely powerful, and they go, hey, how you doing? You already have that in the form of a convergence test, the limit comparison test. If you put 2 things to battle and they come out with a tie, it means they both have to be convergent or both have to be... there you go. Okay, another one. Yes. Let's do basic analysis first. We know that individually this thing tends to 0. That's nice. What's tangent of 0? What's tangent of 0? What is it? It's 0. So does this sequence go to 0? Yeah. Both things that are being multiplied together tend to 0. So could this converge? Yes. It can converge. Why do I like checking that first? What happens if this thing doesn't go to 0? It what? It definitely diverges. So look, if you do this analysis and you show that the sequence, if the sequence doesn't go to 0, then what's true? It diverges, and you're done with the question. So I could give you some nasty limit that no test works on, right? Or series, and all you have to show it doesn't go to 0, and then you're done because you can say it diverges. So this could converge. This could converge. Both go to 0. What does it ask to memorize in this class? You just have to. The derivatives of inverse trig functions. You have to memorize them. Why is it hard to memorize them even though they're not that long? Why is it hard? They look really similar. Okay, so is this one almost like arcsine? The derivative, it's almost, right? What's the one number that messes it up? You have this 9. So we're going to use W substitution and let W equal. Someone raise their hand and tell me what it is. Raise your hand. What should I let W equal? Raise your hand. 然后我说你的名字，然后你说 answer. Chip. 3x, exactly. So what's dw equal, Chip?
3.
dx, right? Yeah. So what does dx equal?
dw over 3.
Yep. So now let's substitute. What type of integral is this? What type? Indefinite. Why? No limits of integration. So we have 1 over the square root of 1 minus what?
U squared.
W squared. Instead of dx, what do we have? Over 3. What should I factor out? So we have 1/3 the integral of 1 over the square root of 1 minus w squared dw. This now is something that we know the integral of. What is that? So we have 1/3 times sine inverse of w plus what? And what does w equal? 3x. So the answer to this is 1/3 sine inverse of 3x plus what? C. There's your answer right there. So people ask, how do you know when you need to use this? How do you know what to substitute? The best way to get comfortable with this, everybody, the best way to get comfortable with this is to memorize the derivatives of all inverse trig functions. Once you do that, you will see things that are super helpful. Why is it imperative? You're going to get at least 2 or 3 questions on the AP Calculus exam, I guarantee it, where you're going to see something like this. Do you have time on the AP exam to figure out what that is manually? No. What's your most valuable asset on the exam? Time. Time. Any.